Hello everybody, Earth.Otherwise here to continue our journey into the book Game Programming in C++, Start to Finish by Eric Yozwa. In Chapter 2, the book will introduce some common software design methods, introduce software reusability techniques, introduce the unified modeling language, describe and cover basic game phases, and describe and develop a design document using the agile design process. Sounds like quite a bit, but really it's just mostly going over how to set up the design for making your game. In reality, so long as you actually end up with a game at the end of it, there's no wrong way to design a game. There are better and worse ways to go about it, though, in the general sense. If you're here, then you probably already know what game design is. There's literally hundreds of videos and posts about it. What game design comes down to is the central idea of your game, a core that you can come back to if you're unsure if you should pursue a certain path. Want to add a double jump? Depends on the design. If your design is about freedom and having cool abilities, then sure. If your design is about realistically simulating life or building an oppressive atmosphere of a horror game, then probably not. There are two main ways that the book talks about when it comes to design: waterfall design and iterative design. Waterfall design is an older form of design that follows a simple principle. You plan things out, get all the details on paper, code it up, fix the bugs, and ship the product. It's the faster of the two design principles. It has a fatal drawback, though, particularly when it comes to game design. Game designers rarely know the full scope of their game before they start work on it. Nor do they know if a certain part of the design is flawed or simply won't feel right to play in the final game. With waterfall design, by the time you're testing your game, it's far too late to find out that one of the main mechanics simply isn't very fun to play. Instead, game designers rely on the slower and more testing-heavy iterative design. Iterative design is simple. You essentially take the waterfall design principles, and instead of making the entire game all at once, you start with a core concept and build the game out from there, much like the layers of a jawbreaker, an onion, or an ogre. Of course, you'll have a general idea of what your game is going to be, and you'll also have deadlines to meet. You will set milestones for yourself to let yourself know if you're taking too long to get part of the game up and running. Each milestone should have a subset of goals that should keep you on track from week to week, and even day to day. At each milestone, you'll want to consider what parts of the previous work took more or less time than expected, and adjust your next set of sub-goals accordingly. Agile design methodologies were created due to the lack of flexibility in software design, and they inform the iterative design process so that we may have more concrete rules for designing software, though these rules are still quite vague. Some methods, like Scrum, have taken this a step further and made very concrete methods, if you need a step-by-step instruction for doing a design process. Essentially, you have several types of maps to use for finding your way to a destination of your choice. Each map gives you a more or less specific route to take to your destination, a video game in this instance. Agile has a few guidelines to follow. 1. Minimize project risk by developing the software in short iterations, here called time boxes, which last from 1 to 4 weeks. 2. Each time box is itself to be treated as a full project and contains all the tasks needed for releasing a full update to the major project. You make a new plan, look at the old requirements and update them, gather any data from the last time box, code, implement, and update the documentation. At the end of each time box, you should have code that, if you released it right now, would run properly and do the things you want it to do. It doesn't need to be something that you would ship, only something that you could ship if you absolutely had to. 3. The design method focuses on personal communication, including direct meetings with your team and with the client. It also stresses that anything you or your client decide overshadows the written documentation. If they originally wanted red and now they want orange, then it's orange. Obviously, when talking with them, if they ask for something you can't do, then mention that what they're asking isn't possible without extreme delays. The way Agile defines the client, however, isn't the way you or I might define the client. You or I might think of the client as the gamers that we're making our game for. Not so in the context of the agile design process. The client is simply the person who defined the project to begin with. In the situation we as indie developers find ourselves, we are actually the client. What this means is that when you are planning on your next time box, you should go with your gut and not be afraid to change things, so long as they don't put undue strain on your workload. It's up to you to decide how much strain you can have. But remember to always underestimate the amount of work you can produce and overestimate the amount of time any task will take you to do. It's also important to note that in 2017, much of game development is multinational. Your artist might be in India or Taiwan, and so face-to-face meetings might not be possible. However, with programs like Discord and Skype, it's easy to have written and voice communication with your team. Along with this, there is Git and GitHub that I'm using. It makes it simple and easy for a disparate team to add to the main project while under the eye of the team lead, likely yourself. Agile design principle number 4. The progress of an agile project is measured by the amount of functioning code at the end of every time box. Makes sense, though you might also want to keep an eye on your assets. You can have a completely functional game, but if all your art assets are crap, then it doesn't much matter how good your game is. Programmer art is most certainly not what most players want to see. You can really only get away with that if you lean into it and go full ASCII or something. Finally, Agile welcomes requirement changes by the client, even late in the project, in order for the client to maximize any competitive advantage. Essentially, if you're making a game like, say, Battleborn, and goddamn Overwatch just came out, you might want to consider delaying your game and doing at the very least an image overhaul. If you don't, well, most of you probably don't even know that a game called Battleborn even exists and came out around the same time as Overwatch, do you? Essentially, the Agile process is specifically designed for you to have a running, shippable game at nearly every turn, and you can easily and quickly change if something unexpected happens, like if your sound guy dies in a car crash. There is another part of Agile, a testing framework to automatically test your software for bugs and crashes. It is outside the scope of this book, but it might be something that we want to invest some time in at some point. As with such a small team, it is likely no one but friends, family, and the team itself is available to test our game, and we need all the automated help we can get. Obviously, Agile has a few flaws. The bigger your team, the harder it will be to turn on a dime and start making a new feature that you didn't anticipate. The Agile Alliance recommends that you use Agile only if your team is 10 people or fewer. Essentially, if you need middle managers, then you'll probably want a more concrete design strategy. Perhaps a mix of multiple design strategies even. That too is outside the scope of this book, though. That's it for part 1. Next time we'll look at the unified modeling language and software reusability. Until then, this is Earth.Otherwise, signing off.